My name's Russ Roberts. I'm a product engineer on the ArcGIS Online team. And I focus mainly on working on the scene viewer and hosted scene layers and hosted elevation layer products in online. And with me is Raluca.
Hi everyone, I'm Raluca. I am a product engineer on the JavaScript API with the Esri R&D Center in Zurich. We work there on two products, City Engine and the 3D part of the JavaScript API.
So just to give you a little overview of what we're going to be doing here today, we'll give you a little intro into like 3D, some concepts on how to create content and some good to know tips. And then we'll dive a little bit into web scenes and how to create web scenes, the different ways you can create them from pro to like online in the scene viewer, and how then we can leverage these web scenes that we are creating to create rich 3D applications. So let's dive into the intro into 3D. So just a little overview of 3D and the platform. Some of the main things that we use are scene layers with feature layers. Scene layers, you can see them being used. We have four main types. 3D object, which is usually used for buildings, you'll see in most demos, but you can also use them for, let's say, large geological bodies for like subsurface. You can use them for multiple things. It's pretty much a 3D object. Scene layer is created from a multi-patch feature. Then we also have feature, and then we have integrated mesh, which is you'll see like the Vricon samples that we saw in the plenary, which give a really realistic scene. We also have point clouds, which we had for the Mud Creek demo in the plenary, which when they're really dense almost looks like imagery draped over the elevation. And then we also have the point scene layer, which is really good when you have like a large number of points. Like a sample I've used, it's all the trees in New York City, which is over 100,000, let's say, in this sample. And then it uses auto thinning, so as you zoom further away, you see fewer trees, but as you get closer to the scene, you'll see more load in. And we also support a number of layers. Every release, we seem to be adding new layers. So we support like elevation layers, WMTS, WMS, map image layers, feature layers, and so on. So we're continuing to grow the layers that we support and have parity that you see with the 2D map viewer. You can use 2D and 3D content in your scenes. You don't have to just keep a focus on, oh, I need to have buildings to create scenes. If you do have 2D content, like the trees, let's say, and you can use those within your scene and then use some of the styles that we provide to style your scene. And yeah, you can use those 2D and 3D layers together. You don't have to just go down one tunnel. You can kind of bridge your content across. And you'll see from Raluca, you can create great visualizations with this. She creates a lot of amazing samples, and then she also documents them in great blog posts about visualizing your scenes really creatively and how you can get a message across in 3D and using some of our smart visualizations. And we use the web scenes as a building block a lot of the times for creating these applications. Raluca is one that talks about it a lot within her blogs. How you can, when you create these web scenes, you can quickly and easily leverage like the slides and environment settings and stuff, because the 4x JavaScript API fully supports these web scenes, so it can read it in perfectly. Cool. Go ahead. So diving in, let's talk about some basic concepts of global and local scenes that you might have seen throughout the week and in some of our demos as well, or if you came by the island. Global scenes, they can support cached layers that are in Web Mercator or WGS84. You'll see on that sample image, you get that sphered curved surface look. There's no fixed extent. So that way, like if you were doing New York City, like in our sample, you could pan over to the West Coast and go to California if you wanted to. But you can also create limited focused scenes by using a local scene, and this supports any like projected coordinate system. This is including Web Mercator. So you wouldn't be able to use your cached data that's in WGS84 within a local scene. you'd have to use something that's in a projected coordinate system. And like in that sample with its recorded earthquakes subsurface in Northridge here in Southern California. So you can navigate above and below ground. You don't always have to have underground navigation on. You can make sure that when you're creating your application that you don't allow navigation below ground if you don't want your users to, if you're looking at buildings in New York City, they don't need to go subsurface within that fixed extent.
So in the code, if you want to create your scene, what you need to do is just to define a new map. And the map is basically like your data model where you store like what kind of a base map you want and the layers, and you set the ground. And then associated with this map, you will have a view, and you can create either a map view for a 2D map, or you can create a scene view for a 3D map. And in this case, I will always use scene view. You have to set the container is the HTML DOM element that will contain the scene, and then the map will be the map that you just defined previously. To set it to local or global, you just have to set the viewing mode global, or in this case here, you will see it is set to local. And again, like the clipping area, here you would just set an extent. I usually use this with the extent of a layer. So once the layer is loaded, you can set this to the full extent of the layer. Like every layer has this full extent property, and you can set it there. Another important concept in 3D is the camera. Each view will have a camera with a position, and the position is X, Y, Z coordinates, nothing special about that. But then it's important to also set the tilt and the heading. So the heading is basically like the northeast, south, like the angle that it does. So north, for example, is 0 degrees heading. And, oops, sorry. And the tilt is the pitch that the camera makes, like the angle that the camera makes with the vertical, the perpendicular to the ground. So if the camera is pointed straight down, then the tilt will be 0, and if it's looking up to the sky, then it will be 180 degrees. Navigation in 3D, you can use navigation like with the mouse or the keyboard, or you can also use it programmatically. We have this go-to method, and there you can set, like you can set a parameter, like for example the geometry, or you can set the position that you want it to go to, or you can set the camera position, and you can also specify like what kind of animation you want to have. You can set the duration of your animation, and you can create really nice animations like this.
So to dive into like one of our layers that to talk about, it's elevation layers. And I don't think many people know that in ArcGIS Online you can create your own elevation layer. So we do offer our own world elevation layers for both the terrain and bathymetry that you can leverage in the scene viewer and in your own JavaScript applications. But you can also use your own elevation layers along with the ones that we provide, or you can use just your own. But some concepts that you want to remember about when you're creating this kind of content, the tiling scheme that you're going to be using on your elevation layers needs to match the tiling scheme that as your base map and other layers that have a tiling scheme. So you want to make sure that you're using the same coordinate system and that you're using that same power of 2 tiling scheme. We don't let you mix and match those together. And how do you even create these elevation layers? You can use ArcGIS Pro, and you use the Manage Tile Cache tool and Export Tile Cache tool to create this to create a TPK with a lurk tile format. And then you just upload that TPK just like you normally do with anything else that was just raster tiles. And the output of it, instead of raster tiles, you'll get these elevation tiles. And then you can just bring those into a scene right away. Also, I have blogs that I've written about how you can quickly create these and host them online. and start using them in scenes. Cool. Thank you.
So how does this look in code? For the Esri World Elevation Service, all you need to do, like if you want to use the default one, all you need to do is to specify the ground property, set it to world elevation, and we will autocast it to the elevation layer that uses the world elevation service provided by Esri. Otherwise, if you host your own elevation layer, then you will need to specify it in the layers property of the ground, and it's just as easy as instantiating a new class of an object from the elevation layer class where you pass in the URL of your elevation service. So there's nothing really fancy to that. Now, passing on to visualization, in 3D, we have the standard geometries like point, line, symbol that we also have in 2D, and you can visualize it with, like we call them point symbol 3D, line symbol 3D, and polygon symbol 3D. They are a bit different because in 3D we have this concept of screen space objects and real world objects, so to call them, and we have symbol layers for each one of them. So when you want to have an icon, or what we would also call billboarded icon, you would set the size in screen size units. But for points, you could also use an object symbol 3D layer, and then you would have like these real world objects, like you can have cones or cylinders or cubes, and then you would need to specify their size in like feet or meter. The same goes for line. You can have these kind of 2D lines, or you could have the kind of tubes in the image below for the path symbol 3D layer. And for polygons, there's the fill symbol 3D layer for a flat polygon, or you could extrude your polygons based on some attribute or with a constant size, and then you would use this extrude symbol 3D layer. And then there's a third geometry, like for scene layer, for 3D object scene layers, we usually use this mesh symbol. And the thing that you can set there is like the color. You would have a fill symbol 3D layer, and basically you would set the color on it. We also have, we call it color mix mode. So for example, if your buildings come with textures, you can choose to keep the textures, or you can choose to replace the textures with the color that you set, or you could desaturate the texture and apply the color on top of it. So just to support several use cases for visualization. This concept with symbols and symbol layers, I think it's not really new for you, because this has been around like in desktop applications. You can choose to have a symbol, and then inside the symbol you would have several symbol layers to be able to make your symbols more varied. Or for example, if you have a line and you want to have an outline and a fill, you would do that with 2 symbol layers. We try to go towards this concept also in 3D. For now, we kind of stick to 1 symbol layer, but we will develop it more in time to come, and hopefully you'll be able to use several of those within 1 symbol.
So let's talk about web scenes. We mentioned them a few times going into this presentation, and so let's actually take a little bit of a deeper dive into it. So these web scenes, they can be authored in ArcGIS Online, or if you're using Enterprise with the scene viewer in Enterprise for Portal for ArcGIS. But you can also create your scenes and share them to Enterprise or to your portal and to ArcGIS Online as well, which is a one-click pretty much. It's a really easy publishing process. You can publish your 3D layers that you can use within web scenes in ArcGIS Online as well in Enterprise using scene layer packages, or publish them with your feature layer as well. And the JavaScript API, the 4x one, also supports reading and writing these web scenes. So if you wanted to write out your own web scene, you could use the API to do that and then read it into your application. And once we create these web scenes, you get an item ID, and that item ID is then leveraged by any of your applications. It could be that you're creating with the JavaScript API, or we'll just leverage that same item ID if you were to use like Web App Builder, Story Map, Cascade, or the configurable apps as well that you can use with that support 3D. So we're using these web scenes to look at this geographic information to give things a different point of view with that 3D environment. And like I said before, you can use your 2D and 3D layers. You can use smart mapping on these layers as well. It's not just specifically to just your 3D object buildings. You can use your point feature layers, point scene layers. We also support smart mapping on point cloud and and the 3D object. And so that way you can create rich looking scenes by using some of these smart mapping options. We also have environment settings. So one thing to make that will show you in a little bit is that you can change the position of the sun, and you can save save that position in a slide, and it gives your scene a kind of a time period that you can reference as a 4 in the afternoon, and then you have your shadows enabled within your scene. So it gives you a little idea of what like downtown New York would look like at 4 o'clock with the shadowing. And that's great for proposals if you're going to put in a new building and you want to kind of give your constituents an idea, or whoever you're proposing this new building to. You can use the shadows to show where the shadows would be cast throughout the entire day to give an idea of the impact that this new building could have on the surrounding buildings. And these scenes are global and local, which we talked about previously. Just so you know that it's not just something that's in the API. This is also something that's in the web scene itself. And just one more thing before I jump into scene layers. We also have our entire web scene spec on the developers.arcgis.com page. So if you want to create an application to write out a web scene, or if you want to fully understand the properties that you're reading in that exist within a web scene, I totally recommend you checking out the web scene spec. Raluca and I both work on the web scene spec team, so we're constantly updating it.
Should I show the website? Or?
Yes, go. Yeah, sure. And Raluca will show you the website. Just in case. And so we do have a web map spec as well on the developers page, but we also have the web scene spec, and it's really helpful to just check out all the properties as it loads up.
Yeah, so here you can see this is the web scene object. This is how it gets serialized, and when you write this with the API, you can then consume it in the scene viewer, so in ArcGIS Online, or you can save it from ArcGIS Online and consume it with the API, or you can publish it with ProWrite and then read it back in the API. So, yeah.
Yep, and just like at the bottom, like we were talking about global and local scenes, this is also something that exists within the scene spec. As you can see, you can have a viewing mode of global and local. And jumping back into 3D, oops. So we do have scene layers. They're created for delivering 3D content into scenes. It's OGC, and we make the specs of these public as well. And like I mentioned, we have the point scene layer, which has auto thinning. That's great for visualizing a large amount of points, and as you zoom away, it'll thin, and as you get closer to it, you'll see more of the layers. The 3D object ones, like in that San Diego scene, they're used for the buildings that you see with realistic textures, but then also the kind of the purple and red and orange ones. Those are also 3D object scene layers that are just been extruded up as well. They're not buildings, but they're there to convey some 3D message. And then we have the integrated mesh, which is great for showing that's a mesh, and it's great for showing like 3D content in the Vricon samples that are collected by drones and stitching these images together. And then we have the point cloud, which is just LiDAR data, LAS, and then you use Pro to create a scene layer package, and then you can upload that to ArcGIS Online or to Enterprise, and then that will create that point cloud scene layer that you can then use in Scene Viewer or 3D application. And then depending on the attributes that are in that point cloud, you can use the like RGB values, classification, intensity, or elevation. And then you can combine some of those, the classification and elevation with intensity, and really get a nice depth perception when you're styling these layers. So how do you create these scene layers in ArcGIS Online Enterprise? We do offer a variety of ways to creating this, these layers and scenes. One of the ways that you can use ArcGIS Pro to create this scene layer package, which is pretty much just like a tile package, but for this 3D content. So you use that create scene layer package tool to create with your like multi-patches, your points, your point cloud, and your integrated mesh. And you'd have that scene layer package which you'd upload to Portal or your organization, and then that would then generate that scene layer that you could use within your application. Excuse me, sorry. So that's one way to publish it, using this package and then uploading it, and that creates that scene layer. But then you can also just share your content if it's point or 3D object, building multi-patch buildings or multi-patch features. You can share it from your scene in Pro to ArcGIS Online and Portal. And what's great about this, beforehand in ArcGIS Online, we didn't have a simple one-click publishing experience to creating this 3D layers. So it was either building that scene layer package or uploading a file geodatabase, and that created a feature layer, and then you'd have a scene layer. But now with the latest release of Pro 2.1, you can easily publish up your web scene and scene layers in a one-click kind of pattern through just this simple share web scene, and that will generate everything for you. So it's a much easier way, a delivery to creating 3D content. But if you don't have access to Pro and you want to create your, let's say, buildings, or you had a large point data set, you could upload a zipped file geodatabase to ArcGIS Online, or a 3D shapefile, and you can upload that to ArcGIS Online, which would create a feature layer. And then we have a simple workflow where you, from the feature layer item, you just click publish scene layer, and then that creates a scene layer with an associated feature layer, which is really good because we use the associated feature layer for like statistics on smart mapping, that like histogram. And then going into the future for querying, for feature search, to be able to search for a building, let's say, we'll be using that associated feature layer behind the scenes. And we also leverage that feature layer to drive the pop-ups as well. So if you configured your pop-up on that for that scene layer, you can always push what's in that feature layer to that scene layer. So to kind of just show you this little simple kind of workflow of what you could do, I'm just going to switch to my. See. Yep, I'm up. So here I have a New York data set that I'm going to be publishing up to ArcGIS Online for Raluca to use in her application. We just have the buildings. They contain some attributes that she'll be leveraging, and just a really basic pop-up. Then I just have some 2D content with all the different neighborhoods within New York. And so what I used, you can use like if you had like simple building footprints as well, you could extrude those up and convert those extruded polygons to multi-patch, and then use those multi-patches to create this 3D scene layer for her to use it within her application. How do you, just to show you the tools, to search create scene layer, and then you'll see the very top one coming back is this create scene layer package tool. So that's in the case of if you don't need this associated feature layer and you just want everything in the scene layer package, which you can use again in Pro, or you could use in ArcGIS Earth as well. You can use that and upload that to ArcGIS Online. But in this case, we wanted to have an associated feature layer with this scene layer. So we're using Pro 2.1. So what we would just do is go to Share, and then to Web Scene. And then we can just begin filling out this basic content about about the web scene, just your normal title, description, the tags that you need. And then if you dive into content, here's where you'll see what you'll actually be publishing up in this one-click scenario to ArcGIS Online from Pro. We have that 3D object scene layer of all the buildings within New York City. We have the associated feature layer. And then we just have this basic 2D layer for all the neighborhoods that we're going to be using within the scene as well. So you have a mixture of 2D and 3D layers within the scene. And so you just can just fill out some of the information. And then you just set your sharing. And then when you click share, what will happen? It'll just start publishing up that web scene with the feature layers, uploading the service definition, and start generating everything for you. And you can track everything in the job. So if you want to check the progression of your scene layer cache that's being built, just look at your jobs and it'll tell you what stage your publishing process that you're actually at. We're not going to just stay here and watch the jobs for the next 30 minutes. For the sake of time, I already have something in the oven ready. So when we go to ArcGIS Online, we won't be looking at that one. What we do, we'd have a simple web scene created, but I'll also show you how you can use the scene viewer to create this content. So we're just here in a global scene right now. If I wanted to start a local scene, on the top right-hand side, I'd go to New, and then I'd pick Local, or I could go ahead and do a global, or I could go through and maybe go back and start off from one of my recent scenes that I just edited within the scene viewer. So let's just add in those New York buildings. So then we see right away the buildings come in. We can click on them, get a pop-up. We highlight these buildings so you know exactly what you're looking at. You can zoom to it as well. But let's also add in our neighborhoods. And this is just a 2D layer. But this looks great. It's a very basic scene. We're using the world elevation. We have our buildings in here, and we have our little points for looking at the different neighborhoods. But let's start creating some extra content in here, or making our scene richer. So we can't really see the neighborhoods right now, but we're just going to use the simple 2D marker symbol. We're going to use black, and let's increase the size to just 10. And that looks great. What you can see is I kind of pan around the scene. I'm losing these points. So what we added in 2017 this call out option. And what it does, it raises your points up on these little kind of sticks, and it looks like a call out. And you can change the scale of these call outs. So this is like a small city scale, but if I choose large, you see my points have just jumped up a little bit higher, which works great within New York City because there's a lot of tall buildings, and they really stand out. And then we can also use labels, and we're just going to use so now we use the name field, and we can pick the position of it on the call out, or on the point. I'm just going to leave like that is, but I'm just going to switch the color to dark. And then just in a few clicks, we have this nice looking, a better looking scene of what we couldn't see in 2D content now raised up in the 3D space, so we can see it around our buildings, and it gives you a good perception of the different neighborhoods within New York City. We also have options that I'm not going to really play with. Declutter. So let's say you had 2,000 points in this scene right now. It would look really messy. So we have this declutter option, which chooses the best points to kind of just in your point of view, so you're not seeing overlapping features, and really makes it look less messy. And something that you might not have noticed, but now I'll point it out, sorry, dry mouth, improve perspective. And so if you looked at the financial district here at the front and the center, if you look at the size of the label and the call out and the point, and then if you look all the way up to Central Harlem, there's a difference in the text size and the symbol size. And it's just a really natural depth perception that you get in this 3D space. So if I disable this, everything from what's closest to us and then what's further from us, it's the same size. But if I enable this improved perspective, then the scene becomes a lot more natural, and the things that are furthest away from us are smaller. The next thing I'm going to do is I'm just going to style some of these buildings. I'm going to use an attribute in there. So I'm just going to use the construction year. And what you see is we're using that, and the scene automatically updates, and we apply our default color ramp for the scene. We can go in and use this counts and amounts option, and we can pick a different color. Let's see. I believe it was this one. Nope, I don't want that one. Raluca's a cartographer, so she's judging every color ramp that I'm picking. And so she's judging on my color scheme that I'm picking here. But you can see that if as soon as I change the colors and stuff, the scene's updating. It's what I showed, actually doing it on an iPad as well at the plenary. And it's really quick and easy. You can use these two sample, or this sample and the one I used at plenary, it's just using counts and amounts, which is just like a continuous color ramp of using the attribute values within your scene layer. But I could also, if I had a unique value, I could use the type style. So if I wanted to go by building type, like from residential to commercial, I could use the types renderer to uniquely render all these buildings within the scene. So I'm going to pick that lovely color that I picked here. And so we have a style of buildings. We now have these raised buildings, raised callouts, so we can see the different neighborhoods. Let's talk about slides. These slides are really useful for navigating your scene for users that might not be familiar with the 3D, navigating in 3D. So what it does, it just captures your camera, which Raluca talked about, but it also captures the environment settings when I talked about shadows and time of day. So I'm just going to capture a slide of all of New York, and then I'll grab one for, let's see, Midtown. I'll give this you can give them a good title name too. This one was New York City. And then let's just do one down here. And I'm just going to turn on the environment settings here over using the daylight widget.
Make a New York by night one.
Yep, and so I'm going to make a New York by night one for Raluca. So what you see here is as soon as I move the time slider, you see the shadows moving with it. And so the position that the time slider is in, once I capture that slide, that's also stored there. So Raluca wants a New York by night option. So I'm just going to do it for 5:30 p.m. And just capture the slide and call it New York City by night. And you'll just see, and what I could do, you can disable or enable shadows, but we want to make this look a little bit realistic and have the shadows enabled. But then if you see it, I just navigate the scene. It moves us around without having to pan and navigate. And then we see the shadows, the environment, and everything that we had saved. So now that I have this scene completed, I'm going to give this one a really good name. New York City. Awesome tags. Useful tags. Once I save it, you'll see that in the URL, an item ID has been added. I could send this to Raluca directly in an email, but we're also members of the same group. So just by clicking on the URL within the scene viewer, it brings me up to the item detail page of that scene. And I want to share it to everyone. So if you guys want to dig it up later, you can find it. And then I'm going to share it to the group that I have for our holistic building of a 3D web application. So now that I've shared this scene to this group, I'm handing it over to Raluca, who's going to create an awesome application with this scene.
Thank you, Russ. I don't know how awesome this will be, but I hope a little bit awesome. So I'm going to show you how to take this scene now and create a 3D web app with it. And we're going to use like the slides that Russ created. And we're going to implement a custom filter. So let me show you how this actually looks like. I'm going to use the Portal API to load the web scene based on that ID that the web scene has. And then I'm going to filter the buildings based on their attributes. I'm going to customize the pop-ups because they're not really nice the way they are by default. And I'm going to use the slides to create a tour. Before I dive into the code, I'm going to explain a bit how this works. So you can see like the scene that Russ created in the scene viewer. It has an ID, and I'm just going to use that ID and use the portal API in our JavaScript API to just load it in. Important about this to know is like we have this loadable pattern in our API where we have to make sure that when we use the resources of a web scene, we have to make sure that it's loaded. So loaded also means that the resources are available and that it's ready for drawing, but it doesn't mean that everything is has been displayed on the screen. You could use the load method on the web scene, and then this returns a promise. So then if it resolves and everything was okay, the ID was correct, you can then start doing things with your scene, like accessing layers or the slides or so. And in case it didn't load, then you would get an error. And you can catch it with this otherwise method. However, I don't really use that load method. What I do is I check, like the view is a promise by itself. And when it's ready, that means that the scene has successfully loaded. And most of the times I just make sure, like I write my code where I access the properties in this view.when. Yeah, that's all there is to it. That's where I can go on and grab the layers or the presentation slides. And now before I move on to the filtering, I'm going to go and take the scene that Russ created. So you can see it in this group. It's right here. I'm going to take this ID and I'm going to pass it in my application here. So this is my app. At the moment, it's pretty dumb. It doesn't do much. I just create the web scene. I load it in a scene view. And then I don't want to have the navigation on the left because I will have my own custom menu there. And I want to add the legend to visualize the legend for the layer. And here I have my view.when. So like here I will put in all the code that I need for the filtering and for the slides and so on. But for now, I've commented all out. This doesn't really do anything. Yeah, I'm going to save this, and then it should reload here. So you can see this is my legend here. You can add your legend to the UI, or you can set here, you can pass in a container. So I have my div element and my ID, and you can pass in the ID of the container where you want your legend to be displayed. And at the moment, my app doesn't really do anything. So I'm just going to explain to you how to filter the buildings. For filtering, we have a property on the layer called definition expression. And you can set in there an SQL query, and that will filter out the features that don't fulfill this SQL query. It's really easy. It's client-side for the scene layer, so it's pretty fast. And what I'm going to implement is filtering of the buildings by their height. And I also want to display, like, this is the number of the buildings that are currently displayed, so that are not filtered, so to say, and 35,000 is the total number of the buildings that I have in my data set. So let's see how to do that. I already have my code in here so that you guys don't see how slow I type. With this function right here, can everybody see it? You're good? Okay. With this function right here, I'm going to go in my layer, and I'm going to go in my scene and grab the layer that has this title. Now, I'm not sure if this is the exact title. I think NYC enrich sample data. So this is the title of my layer. I'm going to copy paste it in here. I worked with the scene that I created, so it's not exactly the same like the one that was created. And this is my buildings layer now. Oops. And I will, after I grab it, I will rename the title to construction here because this is not a really useful title. And now let's see if this should be visible now in the legend. So I have the title of my layer right here. And now that I have the layer, I can perform some statistics on it. So we have in the API the summary statistics method in the smart mapping API. And with this function, you can basically get statistics about your layer. So you can get you pass in the layer. Let me show you here. You pass in the layer, and you pass in the field that you want to get the statistics for. And then it will return an object. I'm going to comment that out for now. You're going to get an object that has information about the count. We're going to see it here. Average height, how many buildings, the max height, the min height, standard deviation, the sum, and the variance. So this is pretty useful, and I'm going to be using this for that count element that I showed you there. I'm going to display it here below the height filter. Now, if I comment this one out, oops. I take the min, I take the max, because I want to build my slider, and I need this information, like what is the minimum height and what is the maximum height. I take the count. The slider, I created it using this no UI slider. You can use it with any library. It's not worth showing. It's not API. It's just a third-party library. And I pass in the min and max. And then I want that when I update the slider, so when the user drags the slider, I get the values, the new values, the min and max from the slider, and I set a new definition expression on my buildings layer. So basically I say, oh, the height roof should be bigger or equal to the lowest value and smaller or equal than the biggest value. And then I also do this query feature count. So query feature count is a method on the layer that keeps track of the definition expression. So then it will only return the features that actually also satisfy that definition expression. And then here I get the count, and I put it in this in the HTML of the DOM element with the ID of counts. And here I have the count with the filter that I get back from this query feature count, and I have the count total that I get back from the summary statistics. I think it's pretty straightforward, right? It's a super useful function. And now my browser automatically reloads. Maybe this is not the best, but like if I save it, then you will see it. Now I get the counts up here under the height filter. And right now I don't have anything filtered, but the moment I start filtering, there are very few buildings with high, or how to say, big heights. Sorry, English is not my tall buildings. But like I think most of them, if you look, most of them are up to 200 feet. Yep. So this would be the filtering functionality. Any questions?
That's a backtick, right? That's not a normal. In other words, the backtick is going up, left-hand corner.
Oh, that's the string template in ECMAScript 6. And it's super useful if you want to write, where's my code? So for example, here, it would be a pain if I would want to split this, but with the backtick, you can just go on the next line and it's like you don't have to do anything. Cool. The next thing that we're going to do, we're going to customize the pop-up. And you do this just by setting the pop-up template on the buildings layer. You might want to have the table that we have by default, but I thought I would just write a nice sentence so that people understand what the, like we sometimes have these cryptic names for the attribute fields and it's not so nice, so I'm just going to put a sentence in there. This is right here. A few people I think know that like usually you're used to pass in the attribute name, but for example for these properties like title and content, you could also pass in a function. And for me the problem was, why did I want to pass a function here? If I would just pass in the name, then many buildings don't have a name, and then you don't get anything in your pop-up. So I wanted to have, I wanted to have a function that will catch that situation, and in case there is nothing, I have no name for the building, then it will just show building. Or you can show something custom. Oh, why isn't this? Buildings layer. Oh, do I have to? I think I might have to put it in a string, right? There we go. Thank you. Yeah, so here this one has a name, but like most of the buildings, they don't, and then I get no title. Well, it's a bit of a silly example, but you get where I'm pointing to. Now you can pass in this function, and you would say, okay, you have to return a string. I'm checking if the graphic has like a name inside, and if the name, for me the names were all empty strings like this. I don't know why it's in the data set like that. So I check for that situation, and if it doesn't have, if it's an empty string, then I will just return building in there. But it's an easy way to to customize a bit your pop-up. Cool. Next thing that I wanted to show you was how you can use these slides that Russ just saved to create this kind of a tour functionality. The tour functionality is a bit like I just go through the slides, like I create this recursive function that goes through the slides. It doesn't even display stop to or anything, so it's just looping through them. You can make it much better, but I just wanted to make a point how you can use these slides in your application to create these animations between different bookmarks or points that you actually set in the scene view. And I'm going to explain the code a bit here. So you get to the slides by going to the presentation property on the web scene. So view.map is actually the web scene that I get. And on the presentation, you have the slides, so you can access them like that. And slides is what we have internally. We call it a collection in the API. I mean, not internally, like it's a collection. It's public API. And you can, in order to get a certain item, it's like an array, but you have this get item at property, and that's how you can get to a certain slide. And each slide has a title that Russ just set in the scene viewer, And I want to get to it so that I can also put it in my application so that users know what they're looking at. Then how there's this method apply to on the slide, and you can use that method to not only go to the location of the slide, but also apply all the environment settings that come with the slides. And it will also store the layers that were visible or invisible in that slide. And then basically I say, okay, I set the duration like those animation options that I told you about. And then this returns a promise once the animation finished. So the promise resolves once the animation finished. And then I can set a timeout because I want to stay there a little bit so that the user has the time to read the title and figure out what's going on. And then I'm just going to increase the slide ID and just move on to the next slide and then call this function again to go to the next slide. So that's basically how I did it. And I'm going to comment it out like before. Oops. And then I have this start tour button, and I added an event listener, a click event listener on it. And then if my web scene actually has slides, I'm going to start the tour. And now it reload it. So you can see also now the environment settings change. So the date and time change, and the title changes here. I set the title here on the lower right. And then once it's finished, then it returns back to the initial position. Okay, that's it. I was like, there was something else. No, there was nothing.
The end slide.
The end, yeah. Cool, thank you. Do you have some questions?
This is going to be pretty fun.
Sure.
A lot of work has been done for 3D flying inside a building. Done animation that way. It's usually done by contractors with the old Google SketchUp, right? Is there any way to pull in that 3D design of buildings and hallways and everything else into this so we can fly through buildings?
So I guess you could publish it as a scene layer.
I can't hear what you said. Have you?
What did you say? Oh, sorry. Yeah. So his question was that a lot of work has been done by the folks at Google and SketchUp to create these animations through buildings, and if we plan to support this kind of like detailed buildings where you can fly through and create animations through for example, a floor plan or so on. I mean, I guess if you have the data for the building, you could publish it as a scene layer, and then it would be exactly what I showed here. Like you could set the viewpoints from where to where, and you could just create an animation. However, I think we still should, we will work a bit to improve the navigation inside the buildings and at the city level, so it's not perfect. I don't want to say it's going to work awesome because you might fly through a wall or things like this. So you have to make sure when you make your animation that it actually takes like the straight path between the 2 points actually doesn't go through walls or anything. So you might have to work yourself a little bit there. It's not like, yeah, but it would be possible.
Okay. Thank you. Is all this on GitHub too, just like everything else?
I'm going to put it on GitHub, and I'm going to show you the link right away. So I have this GitHub account where I put like demos, JS, oh sorry. That's not there yet. It will be.
Top secret?
Top secret, yeah.
Classified?
So I will put it here.
Yeah.
I will put it here, and I'll put it right now after the session.
And so these were the blogs I was talking about earlier that Raluca's kind of written up and walked through. Like the art galleries. Yeah, that's a really awesome one to check out. So yeah, everything that she's written in her blogs as well. Over there.
Thank you.
So it's blogs.esri.com/ArcGIS, and it's getting a big facelift, so it's going to look awesome in a couple
yeah,
weeks.
I'm looking forward to that. Go ahead.
I'm curious about the possibility of eventually taking these web scenes offline. For example, your hiking app, the PWA, is there any push maybe in the future to be able to take these things offline and eventually use it maybe in a higher powered iPhone or tablet?
So are you talking now about the scene viewer?
Well, I guess I'm not sure. I mean, we have the ability to make these cached scenes, say in ArcGIS Pro, right? Is it possible to take that as a TPK or whatever the equivalent is and bring it onto a phone so that I don't have to have internet access if I'm using your hiking app?
Not at the time. And not through like the JavaScript API right now. That would be more on the like runtime team and the like app script like Explorer, because like Explorer for ArcGIS uses mobile map packages and vector tiles and does an offline viewing. And then you could like you could not on iOS or Android, but ArcGIS Earth, you could use your scene layer packages or your elevation TPKs within that globe view, but that's Windows desktop specific.
Right,
Yeah. Yeah. But mobile and that's on the runtime side, and they're looking into it and exploring that. Any other?
I think the story is if you want it completely offline, go with the runtime. Yeah.
Cool. Any other questions? Awesome. Well, thank you guys so much for coming out Friday morning, 8:30.
Thank you.
Thank
yeah.
you.